Okay, so today we're going to take a look at how to graph a rational function. Now we've already gone over how to find all the different key features, so every example I show you today, the key features are going to be listed off to the side because you should already know how to find all of those. It's a matter of now how do we figure out how to put the pieces together, okay? So the first thing you should do for every single graph is draw in your vertical asymptotes and your horizontal asymptotes if there are any. So this function has a VA at x equals -1. So I draw in a vertical dashed line at x equals -1. And then I have another one at x equals 3. So here's 1, 2, 3. I draw a vertical dashed line there. Okay. So there are my two vertical asymptotes for this function. Next I'm going to draw in my horizontal asymptote, which is usually, this one is actually at y equals 0, so that's the x-axis itself. So I'm going to draw it just right above so that hopefully you can see it. But that is right on the x-axis itself. Okay, so we've got our vertical asymptotes and our horizontal asymptotes. Next, we want to go ahead and draw in any holes that we have. Well, we don't have any holes on this particular function, so I'm not going to draw those. Next up will be the x and y intercepts. We don't have an x-intercept here, but we do have a y-intercept at 0, 5/3. So that's 1 2/3. So 0, 1 2/3 will be right about here. So I have a coordinate point right there that I want to draw, okay? So there's my y-intercept. And the only other piece of information that we have is that we are not allowed to cross the horizontal asymptote here. So now it's a question of, well, what on earth could possibly be happening in between? We've got three sections of our graph, one to the left of -1, one in between -1 and 3, one to the right of 3. And we need to draw something in each section, okay? We're going to call these branches. So there are going to be 3 branches for this particular problem, all right? So I'm going to start in the middle section because that's the only place where I have a point. So we're going to have to do a little extra work here to calculate some other points, those confirmation points that I referred to in your last lesson, okay? Now, because this point is above the horizontal asymptote and we know we're not allowed to cross the horizontal asymptote, this entire section has to be contained up here because I'm not allowed to go below that HA because I can't pass through it. So this segment of the graph has to go through this point, has to approach both of these, and it cannot touch this. So it'll look something along these lines. Almost like a parabola, but it gets limited on how wide it can get. Now, if you're not sure, you can pick other x values like x equals 1 and x equals 2, plug them into the function, and see what you get to get more y values, okay? But these are going to be a hybrid between a graph and a sketch. It's going to be a sketch in the fact that our branches are not going to be 100% precise, but it is kind of a more accurate sketch than others because we have specific key features that are in the correct spots, okay? So I've got my middle branch. Now I need something happening on the left and something happening on the right. And the only way to do that is to calculate what we're going to refer to as confirmation points. So I need to pick a number on the left of x equals -1. So I'm going to choose x equals -2, all right? I want to know what's happening at x equals -2. So I'm going to plug -2 into the original function, which I could either go back to the unfactored form or the factored form. Okay, I'm going to work from the factored form. If I do x equals -2, I'm going to get y equals -5 over -2 minus 3 is -5. -2 plus 1 is -1. So I have -5 over -5, those cancel off. This comes out to -1. So that means my coordinate point for x equals -2 is at y equals -1. So I'm going to get rid of this information right here. I'm going to plot my point, which is going to be over at -2, -1. Now I know I have to approach the vertical asymptote. I have to approach the horizontal asymptote. I cannot touch either one of them in this particular problem. So it's going to look something like this. Okay. So it's going to stay below the HA the entire time. It's going to approach the VA and not touch it. It's going to approach the HA and not touch it. Okay. All right. Now I need to look at the right-hand side of the graph and do a confirmation point over there. So this is x equals 3. I'm going to do something to the right of that, so I'm going to do x equals 4. All right, so I'm going to work with x equals 4 next. So when I have x equals 4, I'm going to get y equals -5 over 4 minus 3 is positive 1. 4 plus 1 is positive 5. So I get negative 5 over 5, which is negative 1 again. Okay? So that means I have the coordinate point for negative 1. So my confirmation point this time has a coordinate of 4, negative 1. And again, that point is below the HA. I cannot touch the HA, so I need to stay below it the whole time and approach this VA. So I'm going to draw something that goes like this. Okay. Now these confirmation points do not have to have the same y value. In this particular example, they did match, but they didn't have to. Okay, so that's making a graph based off of the key features and using confirmation points to fill in the missing spots.